Hello everyone. Today I want to talk about something that I think is one of the most misunderstood experiences in modern life: chronic low energy. Not the tiredness that comes after a long day, not the exhaustion you feel after a bad night of sleep. I'm talking about the kind of fatigue that doesn't really lift. The kind where you wake up already tired, where coffee stops working the way it used to, where you get through the day but you can't really explain how. Most people in this situation are told to sleep more, stress less, or exercise. And while none of that is wrong, it almost entirely misses the biological mechanics of why energy breaks down in the first place. That's what I want to get into today. The first thing to understand is that energy in the body is not a single thing. It's not a tank that fills and empties. It's a product, something that gets manufactured at the cellular level, inside structures called mitochondria, through a process that requires specific inputs, clean signaling, and an environment that isn't constantly under siege. When any of those conditions are compromised, output drops. And the frustrating part is that this process can degrade gradually and quietly for months before a person notices how far it has slipped. According to research, mitochondrial function is directly sensitive to both nutritional status and inflammatory load, meaning that what you eat and how inflamed your system is both determine how efficiently your cells can actually generate energy. You can sleep 8 hours and still feel exhausted if your cells are producing energy inefficiently. So what disrupts that efficiency? One of the most significant and underappreciated drivers is chronic low-grade inflammation, the same kind that gut dysfunction tends to produce. In one study, individuals with elevated inflammatory markers but no diagnosed condition reported fatigue levels comparable to those with clinical chronic fatigue syndrome. The inflammation wasn't dramatic enough to show up as illness. It was just persistent enough to tax the system continuously, and the gut is one of the primary sources of that inflammation. When the gut lining is compromised, whether by stress, poor dietary diversity, or disrupted microbiome composition, bacterial byproducts called lipopolysaccharides can enter the bloodstream and trigger a low-level but constant immune response. That immune response consumes energy. Your body is essentially running a background process that never switches off, and that process is quietly drawing down your cellular resources around the clock. According to research, iron deficiency is another profoundly common and consistently overlooked factor in energy disruption, particularly in young adults and especially in young women. Iron is essential for oxygen transport and for mitochondrial function itself. And even subclinical deficiency levels that fall within the technically normal range but are low within that range can produce significant fatigue, cognitive slowing, and exercise intolerance. In one study, this was examined in women who presented with persistent fatigue but whose iron levels were deemed clinically acceptable. When ferritin levels were optimized through supplementation, a significant proportion reported meaningful improvements in energy and cognitive function. Not dramatic deficiency, just the low end of normal. The threshold at which labs flag a problem and the threshold at which the body begins to struggle are not the same number. Then there is the thyroid conversation, which is too large to fully cover here but deserves mention. The thyroid regulates metabolic rate, mitochondrial activity, and essentially the speed at which every cell in your body operates. According to research, subclinical hypothyroidism, where thyroid-stimulating hormone is elevated but still within the broad reference range, is associated with fatigue, cold sensitivity, brain fog, and sluggish digestion in a way that frequently goes unaddressed because the numbers don't cross the clinical threshold. And here is the gut connection that rarely gets made. Gut health directly influences thyroid function. The conversion of inactive thyroid hormone T4 into active T3, the form the body actually uses, depends partly on gut bacteria. In one study, individuals with disrupted microbiome composition showed measurably lower T3 conversion rates. Your gut bacteria are, in part, regulating how much usable energy your thyroid can produce. What I find particularly striking about all of this is how interconnected the drivers are. Poor gut health elevates inflammation. Inflammation impairs mitochondrial function. Mitochondrial inefficiency reduces energy output. Low energy increases stress. Stress degrades the gut lining. The gut lining disruption impairs thyroid hormone conversion. Each of these loops feeds the next, and addressing only one of them in isolation. The picture I'm trying to draw is this: broken energy is rarely one thing. It's almost always a convergence of several quietly malfunctioning systems, each of which is connected to the others. And the gut sits at the center of most of those connections. Improving microbial diversity, reducing the inflammatory load on the gut lining, stabilizing blood glucose, and supporting the nutritional inputs that mitochondria actually need. These are not separate interventions. They are different entry points into the same system. Addressing them together, even gradually, tends to produce results that no single supplement or dietary change can replicate on its own. If this reframed something for you, I'd love to hear about it in the comments. Hit the like button if this is the kind of content you want more of. It genuinely helps this channel reach people who need it. And if you're new here, NutriFlow is where we take the science of nutrition and gut health seriously, without making it inaccessible. Subscribe and turn on notifications so you're here for the next one. See you soon.